an object that may be older than our Sun by up to 3 billion years, is crossing the inner solar system right now. A team in Spain just used ESA's Gaia star map to rewind this comet's path 10 million years, confirming a hyperbolic interstellar origin and revealing an unusually CO2-rich coma seen by JWST. No threat, a once-in-a-generation time capsule we can study for weeks. Let's open it. This isn't clickbait. This is happening above your head at this exact moment. Comet 3I. Atlas isn't just another icy drifter floating through space. It's a cosmic time capsule. Scientists just rewound its journey across the Milky Way for 10 million years. Comment below, what do you think this ancient visitor is carrying? Let me repeat that number because it's almost impossible to comprehend. 10 million years. That's not a comet story, that's a Rosetta Stone from another star, moving at interstellar speed with the clockwork precision of celestial mechanics, passing through our neighborhood right now. The phrase cosmic time capsule isn't mine. It's coming directly from the Center for Research in Information and Communication Technologies, CITIC, at the University of A Coruña in Spain. Their astronomers didn't just observe this object, they reconstructed its entire path across the galaxy, star by star, gravitational pull by gravitational pull. For 10 million years, they literally rewound galactic time. I'm going to give you the facts, the numbers, the stakes, the chemistry that proves this thing came from another solar system entirely. You tell me what it means. Subscribe if you want moment-by-moment updates as new data drops, because this one is big, scientifically, historically, and yes, emotionally. Let's go. The comet was first detected on July 1st, 2025 by the ATLAS survey in Chile. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, NASA-funded, designed to catch objects that could threaten Earth. But this visitor isn't a threat, it's something far more extraordinary. Right out of the gate, it earned the 3I tag. That I is crucial, it stands for interstellar. Third, confirmed interstellar object in human history. After Oumuamua in 2017 and 2I, Borisov in 2019, that I means everything. It means the orbit isn't an ellipse bound to the sun like every comet and asteroid we've studied for centuries. It's a hyperbola, a one-way track, a trajectory that screams foreign registry. This object doesn't belong to our solar system. Never has, never will. Spain's team took that trajectory and did something absolutely audacious. They fed it into Gaia, the galaxy-scale star map, measuring positions, motions, and brightness for billions of stars. And they wound the film backward. Keep watching, the numbers get insane. With Gaia as the stellar roadmap and modern n-body numerics as the engine, they traced the object's likely journey through the galaxy for 10 to the power of 7 years, 10 million years. You're not just watching a comet, you're watching deep time on fast forward. Think about what was happening on Earth 10 million years ago. Our human ancestors didn't exist yet. The continents were still shifting into their current positions. Ice ages came and went. And this ancient traveler, it was already moving, already carrying secrets from another star system. Comment, where do you think it came from? Before we go any deeper, let's address the elephant in the room. Is this thing going to hit us? No, absolutely not. Everyone breathe. The closest approach to Earth is in mid-December 2025, approximately 270 million kilometers away. That's about 1.8 astronomical units, a roomy buffer by any standard. No impact threat, no extinction event, no last night on Earth playlist needed. This is a flyby with benefits, a safe, bright, analyzable lab sample. A messenger from another star drifting close enough for our instruments to harvest its secrets, then sailing on into the cosmic void forever. Drop safe if you're relieved. But here's what makes this flyby so valuable. It's close enough to study in unprecedented detail. Close enough for every major telescope on Earth to point at it. Close enough for spectroscopy, polarization, analysis, composition studies. Far enough to be completely harmless. This is the Goldilocks zone for scientific discovery. Here's where things get mind-bending. Interstellar comets are original recipe. They preserve chemical fingerprints and mineral structures from the protoplanetary disks where they formed, not our protoplanetary disk, not our sun's disk. Other protoplanetary disks, under other stars, in other radiation fields, at other ice lines and temperatures. CITIC's language is blunt and beautiful. Each interstellar comet is like an open window to the past of the universe. Think of it as exoplanetary DNA. You sample it, you read it, you reconstruct the story of worlds that never orbited our Sunday. That's not science fiction, that's spectroscopy. Subscribe now, the shock line comes next. Here's the statement the media will run with, and they're not wrong to emphasize it. The Spanish group, led publicly by Javier Pérez Prieto, says this interstellar visitor originated far beyond the solar system, and their trajectory reconstruction backs it up. The object's path threads through the galactic neighborhood in ways that make local capture extremely unlikely. You don't need to believe in miracles. You need to believe in gravity, statistics, and time. Over millions of years, stars jostle comets. Giant planets kick fragments clean out of their cradles. Most fall silent in the dark. A few, very few, wander into the glare of alien suns. This is one of the few. Comment, how many more are out there that we haven't detected yet? Let me give you the hard data, the timeline, the specifics. Discovery, July 1st, 2025. A-class survey, Chile. Classification, interstellar comet, third of its kind ever. Perihelion, closest approach to Sun, around October 30th, 2025, approximately 1.4 AU. Closest Earth approach, mid-December 2025, approximately 1.8 AU, about 270 million kilometers. Visibility windows, hits solar conjunction on October 2nd, Sun between Earth and comet, then reappears pre-dawn in November, fades through December as it glides from Virgo into Leo. The safe distance never changes. The scientific opportunity only grows. Now here's what makes these numbers even more significant. That December approach, that's our window, our chance, our moment to gather data that might not come again for decades or longer. Every telescope will be watching, every spectrograph will be running, every astronomer will be analyzing, because opportunities like this don't come often. Why is Spain leading this headline? Because the Gaia mission is an absolute game changer, and the team at the University of A Coruña, through CITIC, is wielding it like a time machine. Gaia isn't a telescope pointed at this comet. Gaia is a map of 1.8 billion stars, their positions measured to micro arcsecond precision, their velocities captured to millimeters per second, their luminosities and colors cataloged like a galactic census. When you feed a hyperbolic trajectory into that map and run it backward, you're not guessing where something came from, you're calculating it. You're watching billions of stellar gravitational nudges add up over millions of years. You're seeing the fingerprint of deep time. This is computational archaeology at the scale of the galaxy. And Spain's team pulled it off. Now let's talk chemistry, because this is where the story gets weird. The James Webb Space Telescope turned its infrared eye on this visitor and found something unusual, a coma, unusually rich in CO, 2 carbon dioxide relative to water. That's not normal for solar system comets. Most of our comets are water dominant because they formed in our sun's protoplanetary disk where water ice was abundant in the outer regions. But this interstellar traveler, different story. The CO2 forward signature suggests it formed farther out, colder, or under a different stellar radiation environment. Maybe it formed around a cooler star. Maybe it formed in a disk that was carbon-rich from the start. Maybe it formed in a region where CO2 could condense before water did. This is the chemical dialect of another system. We're hearing an accent in frozen gas that doesn't belong to our family tree. CITIC's researchers put it plainly. The composition tells us about formation conditions we can't replicate in our own backyard. What kind of star system do you think created this comet? Drop your theory below. Think about the implications. Really think about them. Somewhere tens of millions of years ago, maybe hundreds of millions, a giant planet in a distant system nudged a small, cold body out of its natal path. It wandered through interstellar night longer than mammals have been mammals. It passed stars we've never named, through darkness we'll never see. And in 2025, it drifted into our light, long enough for a team in A Coruña to measure its grace and call it what it is, a capsule of time. Let's talk about something the scientific papers don't address: public emotion, because it's part of this story whether we like it or not. Every time a strange object slings through the inner solar system, two ancient human reflexes ignite: wonder and fear.